look at angles inside and outside of a circle and see what we can figure out about them. First, some quick reminders of some information. So a tangent line is a line that intersects the circle at one point, and then just a quick sketch of that. Here's my tangent line. A secant line is a line that intersects the circle at 2 points. So here would be my secant line. And a chord. A chord is a segment whose endpoints are on the circle. Let me go down a little bit so you can see. So a segment whose endpoints are on the circle. So there's three kinds of lines or segments that we come across. It's important to understand what they are and what they mean, because a lot of times they're referenced in questions that we have, and so you need to be able to identify it, or just so you can know what the question's talking about. Okay. So we've learned of three locations for the vertex. So let's take a look at those. Location number one, that is a central angle. Okay, that's location number one. Location number two that we looked at when the vertex is on the circle, and that is an inscribed angle. And then this third location, we've talked about it and looked at it. We just haven't really defined it all that much. It's inside the circle, but not on the center. We've had a few of those. Most of them have been right angles because they have been perpendicular to the chord and through the radius, or through the center of the circle, but we're going to look at some that aren't specifically like that this time. So, just a quick review. This right here is called a central angle. Okay? The relationship between this angle and its arc is they're the same. Okay? And whereas the vertex of the angle, it's on the center of the circle. And I know, like in my class, we've talked about this a couple times. Where is the vertex is a really important question you have to ask yourself when you're doing these problems. This is called an inscribed angle. The relationship between this angle and its arc is the angle is half the arc, or the arc is double the angle, depending on which piece of information you have and which piece of information you're looking for. That's the relationship. And then where is the vertex here? It is on the circle. The vertex of the angle is right there on the circle. So what if the vertex of the angle is somewhere else, somewhere different? What other possibilities are there? So one possibility is that it could be somewhere inside the circle. Okay? So for example, we could have, let me make sure you can see this for a cool looking guy. We identify that the center is definitively right there. That's way too big. But that's where the center is, so that you realize that here's the center of the circle and the vertex is not touching that. So in the circle, but not on the center. And it could also be outside the circle. Okay, outside the circle. And that looks a variety of ways. Okay, or it can look a variety of ways. Sometimes it's not. It's outside the circle, and there are two tangents. Right here we have one tangent and a second tangent. Here it's outside the circle, and we have one tangent and one secant. And then here it's outside the circle, and they're both secants in this case. But just three different ways that one could look, that second possibility. So when the vertex is inside the circle, but not on the center, there's a very specific formula for that. Okay, and what that formula is this right here. It's x plus y over 2 equals the angle. So really it's just the average of the two arcs, and that's the easiest way to think of it. Is the average of the two arcs equals the angle that intercepts the two arcs. If this is A, then this is A also, because of vertical angles. So the average of the two arcs that it intercepts equals the angle. So then let's look at an example problem. This is a problem, and sometimes we get this one wrong for silly reasons. We want to make sure that we set up the problem correctly. The setup is a big deal. First, we're given this angle over here is 20. That's not the angle that intercepts 35 and x. This angle does. So I have to remember that this is a line, and lines have measures of 180 degrees. So these two angles are supplementary. So if this part is 20, then this part right here is 160. So now I can set up my equation, x plus y. So in this case, the two arcs, 35 plus x over 2 equals 160. And then it's really simple, algebra stuff to solve here. I'm gonna multiply both sides of the equation by 2, so that I'm left with 35 plus x equals 320, and then I'm going to subtract 35 from both sides, and I get x equals 285. So that arc is 285 degrees. Okay? You should be able to check your work pretty simply just by adding 285 and 35, getting 320 and divide by 2 to make sure that you get this 160 right here. We are flying through the notes today. Here's some example problems. There's a hint over here. Let's figure out what that says. Don't forget, guys, a circle has 360 degrees. Okay, it's a useful piece of information. So let's take a look at number 1. X and Y are going to be the same, first of all. We know that because they're vertical angles. So X and Y are going to be the same. And it's just the average of the two. A lot of you guys can do this math in your head. 15 plus 85 is 100. 100 divided by 2 is 50. So X is 50 and Y is 50. It's just that simple. Here, this is where we get into a circle being 360. There's a couple different ways to do number 2. You could find this angle right here and then just subtract it from 180 using 73 and 95. I think that's the way that I would prefer to do it. You could also find out what this missing arc is. If you know that a circle has 360 degrees. If you take away 95 and you take away 84 and you take away 73, well, now you know that this arc over here is 108 degrees. Okay? And so, you can find this one and then solve for x, or you can find this missing arc and then solve for x. And at this point, all we're doing is 108 plus 84, and you divide by 2. And that's 96. Okay? Not real complicated. You just got to know the formula. When the angle is inside the circle, but not on the center, we average the two arcs. Here, you can do all the steps, but having an understanding of what is actually going on saves you some time. If this is the average of these two, so 75 is the average of 87 and it's the average of x, then I can figure out average is middle. So if I go down 12 on the number line from 87 to 75, then logically I have to go down 12 more to get to x. So 75 minus 12 is 63. So you can do that without even setting up the problem if the numbers are small and workable and you're comfortable. Here, this is a really commonly missed question because students will just add 120 and 40, get 160, and then tell us that y equals 80. But that's not right. This angle equals 80. These two angles are supplementary, so y actually equals 100. All right? Let's take a look at the next page. So we also have, sometimes the angle is outside the circle. And this equation is very similar to the one we just did, but instead of averaging, whoops, look at that, spoiler alert. Instead of averaging the two, we're going to subtract the two. So instead of adding the two, we subtract the two. And then to make sure that you don't get a negative, you want to do the big arc minus the little arc. So the angle equals the big arc minus the little arc divided by 2. So even though we already saw the answer for just a split second over here, let's do A equals 115 minus 36 over 2. And when you do that math, you'll find out that A is 39.5. Pretty easy stuff. It's just memorizing the formula and applying the right one. That's the hard part. The more of the practice you do, the better off you'll be there. Let's take a look here and see if we can apply that formula a couple times. We have 104, 18, and x, so they're all lined up. You'll see in a second when we do number 2 that matters. So this is 104 minus 18 over 2 equals x. All right. So when we do 104 minus 18, we get what? 86, sorry, 86. And then 86 divided by 2 is 43. Let's take a look at this one. This is where we have to make sure that we're looking at the information that's given. This part right here is 96. This part is 192. To do this problem, I need the two arcs that it intercepts. Okay, this angle right here, this angle is here. Okay, so the two arcs that it is intersecting are this one. I'm going to change colors. And this one. So the 96 is there, but we have to do something before we can use it. We need to know that 360 minus 96 minus 192, that's 72. That's this arc right here. Okay? Now we can use the formula. 192 minus 72 is 120, and 120 divided by 2 is 60. Again, just so you can see it. 192 minus 72 over 2 is y. That's what we're doing there. Okay? Let's take a look at this one. On this number 3, we're told that this is 64, but we're not given this other arc. But we really are, if you think about it, because 360 degrees are in a circle. So if 64 are used up, then this is 296. And then we just are going to take 296 minus 64 divided by 2, and we get 116 for x. And again, that formula there was 296 minus 64 over 2 equals x. This is probably the hardest or most difficult, or really from a teacher's perspective, the best problem on the page. I'm given the angle this time. Okay, so remember it's big arc minus little arc over 2, but I'm given the angle. So 40 equals the small arc is x. Well, I don't know how much the big arc is, but there's only two arcs here. Okay, let's be clear about this. This light blue arc is x. Okay. And this light green arc is the rest. Okay, so that's right. So there's only two arcs. Well, if there's only two arcs and one of them is x, and we're talking about a circle, then the other arc has to be 360 minus x. If this is 50, that's 310. If this is 100, that's 260. If this is 200, then that's 160. We don't know what exactly it is, but I do know that these two, when we add them together, and I'll even show you over here, if I add 360 minus x plus x, I get 360 degrees because these add up to 0. So I don't know what this is, but I know that it's the difference. It's 360 minus whatever this blue arc is. So that's what we do. Okay? I'm going to take the big arc, 360 minus x, and then I'm going to subtract x from that, and divide it by 2, because it's big arc minus the little arc over 2. When I multiply both sides by 2, I get 80 equals 360 minus 2x's. I combined like terms there. Subtract 360 from both sides, and I get negative 280 equals negative 2x, and x equals 140. Now I should be able to check this here. Like, you want to go back and look at this and see, does it make sense? So if this is 140, this should be 220. 220 minus 140 is 80, and 80 divided by 2 is 40. Look at that. It works. Okay? That's it for this video. Pretty simple stuff. You should try 8F on your own. I'm going to make a video for it, but your teachers may want to go over that in class. So, try it. Don't try it. It's Sunday afternoon and the weather's nice. Do what you want. Okay? Have a blast. Buckle your seatbelts and watch out for red dye 40. That stuff is real.